بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. This experiment examines how bending moment varies at the point of loading, and we can see here in this figure that we are going to have a beam like this, and this beam is supported at this location and this location, and there is a cut here provided in this beam, and we can hang loading at any location along the beam. We are going to measure the bending moment at a cut location in the beam. Before we start the experiment, we need to derive an equation that calculate the bending moment at the cut location. For that purpose, we have drawn here the free body diagram of the beam showing the support here RA and support RB and the cut location here, which is an A distant from RA. The length of the beam is L, and the weight which we are adding to the beam at the cut location is W. This equation shows us how to calculate the bending moment at the cut location, which is equal to W times A times L minus A divided by L. Here we are going to explain how to derive this equation. First, we need to calculate the value of RA and RB. So we take the moment at A equal to 0, and this gives us the equation L times RB minus WA equal to 0, RB equal to WA divided by L, and then we take the summation Fy equal to 0, and this makes RA equal to W minus RB, and this makes RA equal to W times L minus A divided by L. And now we draw the free body diagram after we make the cut. And to find the moment at the cut, we take the sum of moments at the cut location, and which is here sigma M at the cut equal to 0, and this gives us the equation M cut minus RA times A equal to 0. So M at the cut equal to RA times A, which is equal to W times A times L minus A divided by L. Now, according to the equations derived so far, if A equal to 0.3 meter and L length of the beam equal to 0.44 meter, and if W equal to 100 grams, then RB equal to 100 divided by 1000 times 9.8 times 0.3 divided by 0.44 equals to 0.67 Newton, and RA equal to W minus RB, which is equal to 0.98 minus 0.67 equal to 0.31 Newton, and the moment of the cut according to the equation will be equal to 0.98 times 0.3 times 0.44 minus 0.3 divided by 0.44, and it's equal to 0.094 Newton meter. So let us check this on the experiment. As you can see here, if we had 100 grams load at the cut location, it will induce 0.98 Newton at the cut location, and RB equal to 0.67 and RA equal to 0.31. Also, when we add the load here at the cut location, the 100 gram loads, it's reading here 0.9 Newton at the load cell display here. Now, after changing the loads one by one, we have reached up to the 400 grams load, and we can read at the cut location 2.3 Newton force, and we can record this on the table as 2.3 Newton force, and the load which was added was 3.92 Newton. Now we need to calculate the experimental bending moment by multiplying this load displayed on the force meter by 0.125 to calculate the experimental bending moment, and also we need to calculate the theoretical bending moment using the equation which was explained before. Now, after calculating the experimental bending moment and the theoretical bending moment, you need to plot a graph which compares your experimental results to those you're calculating using the theory. Comment on the graph and what does it tell you about how bending moment varies at the point of the loading. Does the equation we used accurately predict the behavior of the beam? So write your thoughts about this. Now in experiment number 2, we are going to see bending moment variation away from the point of loading. In this experiment, we are going to examine how bending moment varies at the cut position of the beam for various loading conditions. In this figure number 4, you can see that we are going to hang 400 grams load, which is equal to 3.92 Newton at the end of the beam. And we are going to calculate RA and RB and measure the force at the cut location. The force at the cut location is equal to minus 1.4 Newton, and here is the 400 grams load hanged at the end of the beam. Now, to convert the force reading into a bending moment, remember that bending moment at the cut is equal to the displayed force times 0.125. Calculate the support reactions RA and RB and calculate the theoretical bending moment at the cut. In figure 5, we are going to add the 200 grams and the 400 grams at 220 millimeters and 260 millimeters from RA, and these are the loads added here, and we are going to measure the force at the cut. The force displayed here is 3.5 Newton. We are going to record this force in the table here, and we are going to calculate the experimental bending moment and RA and RB and the theoretical bending moment. In the experiments explained in figure 4 and figure 5, we need to convert the force reading into a bending moment, and remember that bending moment at the cut equal to the displayed force times 0.125. Calculate the support reactions RA and RB and calculate the theoretical bending moment at the cut, and record your calculations and the measurements in this table. Comment on how the results of the experiments and compare with those calculated using the theory.